Good morning, class. Welcome to the online classes for physics of class 9. We were learning about the chapter gravitation in the previous classes, and we are going to the end of this chapter. So, see a quick revision for the whole chapter. What are the topics which we have learned? And beside this, we will be going through the revision of the first and the second chapter also. So, if you have any queries relating this chapter, then you can ask me. Okay. So, just fastly go through the revision of the whole chapter and what are the topics which we have to read about this chapter and what we have learned in the previous classes. So firstly, we have learned that what the gravitation was. We can say that on the earth, every object is exerted towards the force, and that force is of the attraction, and it is due to the earth. So we can say any force of attraction that is exerted by the earth on any object that is present on the surface of the earth is said to be the force of gravity. That is the gravitational force. And we have seen various examples that when we see that whenever object is dropped or thrown upward direction, then every object comes towards the center of the earth, and this is due to the force of attraction acting towards the center of the earth, and this force is known as the force of gravitation, right? And we have seen after that what is the universal law of gravitation. That is, whenever the two bodies present in the universe exerts a force of attraction on each other, and this universal attraction between each other is said to be the universal gravitation. And we can say that the force acting on between these two objects can be defined as the product of their masses and inversely proportional to distance between them, and that to the square of the distance between them. And together we can write, if these two equations are right together, then we can say that force is directly proportional to m1 m2 upon r square. And if this proportional sign is changes into equal, then we can write it as g m1 m2 upon r square. And here the g is a constant, and to show these constant we named it as a universal gravitational constant. Okay, so we can say that the universal gravitational constant will be equal to f r square upon m1 m2. From here we can find the unit of the capital G, that is the gravitational constant, that is force. Unit of force is Newton, and r square, that is unit of distance square, will be meter square, and upon m1 m2, that is kg into kg, it will be kg square. So we can say that the unit of gravitational constant G is Newton meter square per kg square. And we have learned that there are various effects of this gravitation throughout the universe, that these planets revolving around the sun is earth revolving around the sun is due to the gravitation, or the moon that moves around our earth is due to the force exerted by the earth, that is the gravitational force. And various other examples, we know that in the seas we can see that the high tides and the low tide, these tides in the seas is formed by the rising and the falling of the gravitation itself. So the water level is allowed to move forward or to the highest tide to the lowest tide is due to the gravitational force of attraction. Okay, and this is the gravitational force of attraction as the moon and the earth and the sun exit on the water surface. Okay, so therefore we can say that in the during the eclipse time, this sea tides used to be very highest of their height. So the gravitation and the force of attraction is due to the sun and the moon on the earth. Okay, and from there we have seen that Kepler gave the planetary motion about the motion of these planets around the sun, and these planets, and what he told about that, that these planets move in orbits around the sun. But he had given three laws through which we can say that the exact position and the exact revolution of these planets around the sun. According to the first law, the planet move in the elliptical orbits around the sun, with the sun as one of its foci. That means the sun is as a focus. These planets revolve around the sun in an elliptical orbit. So we can say that it is not a circular form, it is in the elliptical form, that it will be has some major axis and will have some the minor axis. And in the second law, what he tells is that every planet revolves around the sun, sweeps equal area in equal interval of time. Means every area, whenever it moves around the sun, will be of equal area in equal interval of time. Means they will sweep equal area, and that too in the equal interval of time. So planet moves around the sun. When it is closer to the sun, they move slowly, and when they are farther from the sun, they move forward very fastly, so that the time should be of equal interval. Okay, and third law, what he told, that the distance between them, the mean distance of the planet from the sun the cube of that distance will be directly proportional to the square of the time period, that is the time required for the planet to revolve around the sun. Okay, so that is r cube is directly proportional to t square. So we can say that r cube upon t square will be a constant. And after that we have seen that the free falling body or a free falling object, this free fall means that whenever an object is falling from a height towards the center of the earth, and there due to the influence of the gravitational force of the earth, so we can say that no other forces is acting on that object. The only force which is acting on the object can be given by the gravitation. So we can say that any object which is fall under the influence of the gravity is said to be the freely falling objects. And we have seen various examples, that is a bungee jumper, or when we allow to fall any object from the height of the terrace, then also the object fall under the influence of gravity. Okay, and after that we have seen that the acceleration due to gravity, we can say that whenever we drop an object from a height, we don't need a velocity to drop it, and when it comes towards the center of the earth, it attains the highest velocity, or velocity increases. So we can say this varying velocity as an acceleration, and these acceleration is said to be under the influence of gravity, so that is due to the gravity, so that named as the acceleration due to the gravity or the gravitational acceleration. It is denoted by the letter small g. So we can say g as equals to the F take as force equals to mass into acceleration. From there also we can put the value of acceleration as an acceleration due to gravity, that is g. So g can be given as gm upon r square, and if we find out the value of the acceleration due to gravity on the earth, then it is 9.8 meter per second square. Its unit is 9.8 meter per second square because it is a form of acceleration, so the unit is similar to that of the acceleration. And after that we have read about the equations of motion, that's similar to that of the first chapter, in which we have learnt three equations of motion: v is equals to u plus at, s is equals to ut plus half at square, and the third equation of motion, v square is equals to u square plus 2as. But for the freely falling body, then we know that for the freely falling object only the gravitation works out. So under the influence of the gravity, these acceleration, that is a, will be taken as g, and the s, displacement, will be taken as height. So displacement will be taken as the height, that is h. So s will be replaced by h and a will be replaced by small g. So the three equations for the motion of a freely falling bodies can be given by v is equals to u plus gt, that is the first equation, and the second equation h is equals to ut plus half gt square, and the third equation v square is equals to u square plus 2gh. Okay, so these are the three equations of motion which will be useful for you in solving the numericals. And the numericals in the extra 3 points which we have to remember is that whenever the body is falling from the upward direction to the downward, then we can say that we don't need a velocity, right? We don't need an initial velocity to let the body fall downwards. We just can drop it out freely, and when this freely falling body comes downwards, then the only force acting on it is the gravitational force. So this body moves very speed due to this gravitation. So the acceleration due to gravity makes up this body to fall downwards very speed. So this acceleration is said to be as a acceleration due to gravity, that is g, and it is in the direction of the falling body. So we can say that the g can be taken as positive, and when we allow the body to move upwards or thrown vertically upward, then the velocity decreases, right? We have to throw it with some velocity, but avoiding our velocity, the velocity decreases. Here also the acceleration is there, but due to g, this velocity is decreasing. So we can say it is in the opposite direction to that of the acceleration due to gravity. So the value of g will be negative, that is minus 9.8 meter per second square. And the third thing which we have seen is whenever a body is dropped freely, that from a height, then the initial velocity is needed or not, because we used to fall, make a body to fall downward direction. So no velocity is needed to fall it. So we can say that the initial velocity will be 0, and we need some velocity because our body, when it falls downwards, its velocity increases. So there is some velocity, so we can say that v will have some value, but u will be 0. And secondly, we have seen that whenever body is thrown vertically upward direction, then we need some velocity to move it upward. So we can say that u will be there, but after reaching to a maximum height point, the gravity will work on it, and the velocity with which we have thrown will stop over there. So we can say that the final velocity of that object will become 0. So v will 0 and u will have some value. So these 2 points will be required for solving a problem. And if you see the fifth point, this is not required for the problem solving, but for the conceptual you can read this, that time taken by a body to reach the highest point from us will be equal to the time taken to fall from the height to the downward. So we can say that the time taken by the body to reach to the highest point and come backward or to return to the earth will be of the same time. So time period is same required to body to get to the reach highest point and to get downward towards the gravity. And after that we have read about the concept of mass and weight, and we have read that mass is a quantity of matter present inside any body, and whereas the weight, we thought that mass and weight is same, but by differentiating we came to know that mass and weight are different quantities. And weight is a kind of force of an object which tells us that it's attracted with what force which it is attracted towards the earth. So we can say it is a kind of force which tells us about that, about what with force it is attracted towards to the center of the earth. So weight is a force and mass is a quantity of an object, and we know that mass cannot be changed, mass is constant, and weight can be changed because it depends on the value of the mass as well as the gravity. Since we know that force is equals to mass into acceleration, here we can replace the force by weight and acceleration by acceleration due to gravity, that is g. So we can write it as w is equals to mg. So weight depends on the mass and the gravity. So if gravity changes, because when we reaches to the highest points or when the height changes, then the gravity's value will also vary, and if the value of g varies, then the weight will also vary. So we can say that weight is not constant, it can change due to the gravity changing value of the gravity. And the SI unit of mass was kg, because it is only the quantity present inside the body. But weight, the unit will be Newton, because it is a force with which it is attracted towards the earth. And mass of an object cannot never be a zero, because the quantity cannot be replaced or cannot be negligible, because every body has some quantity present inside it. We can just empty it, but we cannot totally negligible the mass. So mass cannot be zero, but weight can be zero, because of the gravity working on the body is zero. Then we can say that the mass value will be multiplied to zero, so the weight will be 0. So weight can be 0 if the value of the g will be 0 or the mass will be 0, but we know that mass cannot be 0. So the only value on which this weight will depend will be the g, that is if g is 0, then the weight can also be 0. So mass cannot be 0 and weight can be 0. These are the conceptual questions which will be used in the exam, so we can see these points in the exams also. And if you think that you want more numericals to study, so you can just inform me, we will be doing it in some other video for the numericals. And if you watched my last video, then you can see how to solve a numerical, because for the next days we will be seeing the previous quick revision for the chapters which are going to come in your first term exam, that is motion, and the second one, that is the force and the laws of motion. Okay, so if you have any doubts, you can just ask me.